Audio Jungle. Audio Jungle.
All right, so I will write the longitudinal dynamic stability, right? Correct. In longitudinal dynamic stability, definitely we'll talk about the first of all dynamic stability. You should know dynamic stability is nothing but time response with respect to time. What is the response of the aircraft after the disturbance? That will define the dynamic part. Okay. Earlier it was static. The initial tendency to come to its original position is the static stability. Dynamic means once the aircraft comes and once the disturbance comes and hit to the aircraft will, uh, because of the disturbance, it will be change its orientation. The aircraft will change the attitude because of the disturbance. But as disturbance gone, then it will try to come back to its original condition, to initial condition. And meanwhile we have to check the response, time response, what time it is, finite time or it is infinite time, or without any oscillation it is coming to its initial condition. So with time response we have to check, like, time response in the sense, as I have told you, it should come to its initial condition, to original position, but in finite time of period. Means if it is oscillating because of the disturbance, so the oscillation should be damped oscillation. Damped oscillation means that amplitude should decrease, that should be convergent oscillation. I will show you all three. Okay, so it's a time response. Dynamic means it's a time response. All right. And because here already I have told, talk about the longitudinal, because same thing will have a lateral and directional. So if I'm saying longitudinal, so definitely this longitudinal is what relates to the pitch up and pitch down. Pitch up and pitch down. So doesn't mean that disturbance comes and only there will be a longitudinal stability uh, condition. No, once disturbance comes, there will be lateral, there will be directional also. So one by one we are covering here. First we are talking the longitudinal dynamic stability. Okay, so once a disturbance comes and hit to the aircraft, then what will happen? The aircraft will be disturbed from its initial condition to final position, and once it disturbed, then how it comes to the initial condition again. Okay, then there are three possibilities. That three possibility we have to discuss. Three possibility. Three possibility. Concentrate. Three possibility. What are that? See, three possibility. After the disturbance, the aircraft will response there, the time response, and in that time period, that aircraft will have maybe uh, no overshoot. I will write one by one, so then I will explain. No overshoot. No overshoot. That means it is also called heavily damped. Heavily damped. Damped is also sometimes called dead beam. Please remember, dead. I will show the graph also more clear. That is the one possibility. Second, oscillations die. Oscillation die away. Oscillation die away, which is called slightly. Slightly damped. Third one is the Oscillations divergent. Divergent, also called undamped. We are talking about the longitudinal dynamic. So after the disturbance, that aircraft will response, time response. That means dynamic condition of the aircraft after the disturbance. It may try to get back to its original condition, but there are three possibilities. In three way that aircraft can return to its original condition. That is the mean of it. Three possibility means after the disturbance. I'll show you so more clear. Suppose see the here this is the check. This aircraft is what flying. Once disturbance came and hit to the aircraft, once disturbance came and hit to the aircraft, suppose that crosswind came here. Suppose the crosswind came here. This is also the one kind of disturbance. When crosswind came, it's also called disturbance. When disturbance came and hit to the aircraft, okay. Then what will happen? This aircraft will change attitude. Aircraft is what somewhat like this. The aircraft now. Check the orientation has been changed. Means there is the nose up condition. Why it is now nose up condition? You have not done anything. Pilot has not done anything. Only because of the disturbance. It is disturbed. So from its initial condition, that attitude of the aircraft has been changed. Okay. Now it is nose up condition. So again, because it is flying with very high speed once nose up condition, so again that angle of attack will be keep increasing. So initially the aircraft should have initial tendency to get back to its original condition. That will be the static stability. But during once the aircraft is not uh, coming to its original condition, directly it will not come, right? It's not a solid body, it's a floating object. So obviously if it is a floating object, so once it will respond, that time response, that aircraft will come to its original position, but in different way. So all three different possibilities I have explained you, like no overshoot means heavily damped. Heavily damped means that aircraft is what directly coming to its initial condition without any oscillation. Heavily damped means uh, damping. I had explained in vibration, if you remember. So it is just like the object is what without any oscillation, it is coming to its original condition. That is the heavily damped. It is also called deadbeat. Deadbeat or no overshoot. So once that aircraft will get back to its original position, because it is very dynamic, stable aircraft. It is very dynamic, stable aircraft. So it will come to its original position without any oscillation. That is called uh, a highly damped oscillation. This is one highly damped oscillation. Second, here I'll show the diagram also. Oscillation die away. Means whatever the it will oscillate. That time response will be there. Means we are talking about dynamic stability. So time response with respect to time, the oscillation will die away. Oscillation will die away means that amplitude will be decreasing, and in finite time of period that amplitude becomes zero. So again it will have the same uh, orientation, same attitude of their aircraft you will have. So that is the slightly damped. In damping will be there, but it is not highly damped, heavily damped. It is slightly damped. Means slowly and slowly it will get its original position, or it will get its original condition. That is the oscillations die away, slightly damped. Third one is the oscillation divergent, undamped. Damping means in a vibration I have told you. Damping means what? The amplitude will die when that amplitude die out. So basically the amplitude will be decreasing. That's the mean of it. The oscillation die away. Oscillation die away means the oscillation is what? Slowly and slowly it is going to die away. Means the amplitude will be decreasing, and later on it will have a zero amplitude. There is no oscillation at all. There is no displacement as all at all, right? So, but if it is the oscillation is what divergent or undamped, so undamped means it is not going to damp out the oscillation. It is not going to damp out the oscillation. Undamped means oscillation is not going to die out in finite time of period. It is divergent. Oscillation is what divergent. That means amplitude is what continuously increasing. And to continuously increasing means what? The aircraft have a pitch up, pitch down, pitch up, pitch down, and it will keep increasing. And think if it is keep increasing means it is completely unstable here. I hope you understood this three possibility. Now all three possibility I will show you with the graph so it will be more clear to you. See, check it now. So first I will show you the uh, did beat. First one I have here. I will write the numbering. So one, two. Okay. So no overshoot or did beat. First one is no overshoot, or which is also called heavily damped, or also called did. There is no beat at all. And that means there is no oscillation. That's the mean of it. Correct. If you do this by the graph will be somewhat like this. So after the disturbance, that aircraft will response. Time response will be there for the aircraft, but that amplitude will be decreasing like this. Check the graph. Here it is nothing but displacement. I must say displacement. Y-axis is displacement, and this is nothing, obviously time. Correct. So if it is the no overshoot or dead beat, the aircraft will respond after the disturbance something like this. You see the graph, check. Immediately it will comes to its initial condition without any oscillation, and it is heavily damped. It is heavily damped means immediately it comes to its origin. It will not take time. It is slightly damped, so slowly and slowly it will have a decrement in amplitude. But here it is very fast amplitude will decrease. That's the mean of it. Very fast in the sense it will not oscillate further. The meaning is from disturbance to its initial condition immediately it comes, which is very impractical. You think about it, the object is what floating in air. How it comes uh, from nose up to immediately it comes to the initial no. From nose up to it again it will go nose down. Then again nose down to nose up to nose down to nose up. That will continuous and slowly it will achieve its initial condition. So that is the second case. But anyway, you hope you understood. Dead beat means there is no oscillation at all. Heavily damped means without any oscillation, it initial condition, original. Immediately that amplitude is displacement is what becomes zero here. Means what was the disturbance? Immediately after disturbance, the aircraft will get back to its original condition. That's the mean of it. Second, which is nothing but slightly damped. That second diagram I will show you, which is called slightly damped. What it is called slightly damped, or you see, is also called oscillation. Rightful oscillation die away. Slightly damped. First of all, you should very clear about it. They have mentioned oscillation. The oscillation means obviously there will be a harmonic vibration. I had explained you that oscillation will be the simple harmonic motion here, and that oscillation die away means that amplitude is what going to decrease because it is slightly damped, so the amplitude will decrease slowly, right? So see the graph. Another graph will be somewhat like this. Check it. See, this is what time, and this is what check. What this right? And what will be the graph for this particular, see, amplitude displacement is what here, because of the disturbance this is the amplitude, because of the disturbance this is the amplitude, you can say this is but x now. So because of the disturbance the aircraft is what now here, this is the uh, orientation of the aircraft, you can say this is the, not like this exactly, it will be somewhat like this to you, because of the disturbance the aircraft will be there here, like like this. So there will be amplitude, huh? I mean it is displaced from its initial condition, it is displaced, the displacement will be there, just say the displacement is what x now. But as the time is what increasing, will start oscillation, but slowly and slowly will achieve its original ticket. Later on, it will have a zero amplitude. I hope you all understood. See the graph. Check. The amplitude is what? Oscillation is what die away. That oscillation is what gone after the disturbance. So this is the required. This is the desirable actually. Slowly and slowly it comes to think, if this is what the passenger aircraft, what will happen to the passenger? The first case is a dead beat or heavily damped. If passenger is there and passenger, for the passenger aircraft, if suppose it happens, then what will happen to the? There will be a jerk. Yes or no? There will be a jerk for the passenger. Huh? Because immediately from disturbance it comes to its initial condition. How it is possible? Not possible. So that is not desirable actually. Even though not possible, it's impractical, because the floating body immediately it comes to rest condition. That is not possible. So the second case, which is very feasible, and that is happening to the aircraft. See, the after disturbance, the aircraft will achieve its initial. Suppose this is the initial. Now that aircraft will have this attitude, this orientation of the aircraft will have. The aircraft will go up, down. The aircraft will be here. Again, the aircraft will be right. Huh? And this is the amplitude basically. And slowly it achieves its initial condition. I hope you understood. Correct. So this is the second case. What happens to the third case? Now think about it. Third case means it is nothing but the divergent oscillation. Oh, okay. And also you can mention here, this is the convergent, that oscillation, which is third one, is nothing but oscillation divergent, right? Oscillation, oscillation divergent, divergent, and this one is what? Convergent. One is also called convergent. Okay. Convergent means amplitude is what? Decreasing. Divergent means amplitude is what? Increasing, which is not desirable. See this graph, if you check, this is what time, this is what amplitude. Because of the disturbance, the aircraft is what? Reach at this position. Now graph is started. See, that will continuous. That amplitude is what? Continuously increasing. It is undamped. It's called undamped, which is unstable condition. So always remember, three possible three possibilities are there. This one is called divergent or undamped, which is completely unstable condition. In the stable condition, the stable condition is the convergent oscillation. Second case. Okay, now you think about it. Based on this, we have three types of the oscillation, two types of the oscillation, two types of the oscillation. We have short period pitching oscillation and long period. Okay, two types of the oscillation we have to talk for the this pitching oscillation here. Okay, now check. So I'll give here pitching oscillation. Pitching oscillation. Check oscillation. Types of the oscillation we have. So if I'm saying oscillations means for what I'm going to discuss for the second one. First is not possible, it is very impractical. Third is possible, but again it is not desirable for our aircraft because it is a unstable condition. So third is possible, but not desirable. Your aircraft is what not have any control surface to control the oscillation. It is not well designed. So definitely after the disturbance, once disturbance came and hit to the aircraft, so it will not able to get back to its original condition. For that reason, you are using control surface get back to its initial condition. You are using control surface. Suppose that control surface you is not available. So once disturbance came and hit to the aircraft, then this third case will happen. Okay, because you have designed well your aircraft. Okay, and there is the control surface. So second case is the practical and which is desirable. So now for second case, that's the reason here it is written oscillation. Oscillation means that that second case slightly damped convergent oscillation. So for convergent oscillation, I'm going to talk convergent. Second case for convergent oscillation, I'm going to talk. So for second case, two possibilities are there. What are that? Because oscillation is there and it is the convergent as well. So it is a stable condition. But this is dynamic stability that aircraft will achieve. But how it will achieve? There are two ways. One, short period. One is nothing but short period. Short period of pitching oscillation. Short period pitching oscillation. Okay. Oscillation and second is nothing but long period oscillation. Okay, now think about it. If I'm talking about the short period oscillation, so I'm talking here short period oscillation means uh, time period t. See this time period t. Time period is nothing but t here. Okay, and frequency, if I say, just like in vibration, I have discussed natural frequency, nothing but W. Always remember W is the frequency. That will be obviously in radian per second. So if short period oscillation means time period is what? A less. Short period oscillation and long period oscillation. So time period short period oscillation means time period is what less. If time period is what less, then you know the formula of the that frequency. What is the time period? Total distance, that is the angular distance, 2 pi divided by w, angular velocity. Generally, this is the formula. So time period and angular velocity, which but frequency is always opposite. If time period is less, that means frequency will right. If time period is less, then frequency will always remember. And here long time period, so time period will be a long. The frequency will be. Please remember this is very important. All the problem it right. So if you are talking about the short period oscillation, see, in the short period oscillation, there are few things you need to remember. Short period oscillation. So see what is happening in case of the short period oscillation. Generally, to the few things are the a few points are important. First, you write down, then we'll discuss as the definition itself. It's a short period, right? Short period short period oscillation, see, we have the short period mode is excited by a change in angle of attack. The change could be caused by the sudden gust, which is nothing but disturbance. I will write here. And the longitudinal displacement of frequency, which is the uh, uh, it with the stick. Then what is happening here in the case of the short period, that altitude will be constant. Altitude. This is the important outcome. I just want definition not required. Altitude is what is constant. This is the outcome of short period oscillation. Meaning is short period oscillation means something like this. You think about it. This is the suppose one altitude here. Once for the short period oscillation is there, then what is happening to the aircraft? Suppose this is the aircraft here. Think this is the aircraft here. Once disturbance came and hit to the aircraft, so this aircraft will go up. Then okay, will go like this. Then it will go down little bit. Then again it will go and again like this. See, this is the short period oscillation. What is happening? That's a very simple. Even though it's a short period oscillation, but that uh, altitude is what constant. It is not going to change. It will go up, nose up, because it's a uh, short period pitching oscillation. Pitching oscillation means what? Nose up, nose down, nose up, nose down. But if you see the overall amplitude, overall altitude, that is the height. With respect to the reference, if you see the height, altitude, it is what constant. Altitude is what constant everywhere. It is not going to change. It is not going to change. Altitude is what constant. That is the first outcome. For 1 marks, they are asking. Okay. What is the second outcome? See, if it is going nose up and nose down because altitude is constant, so the angle of attack will be changed. The angle of attack. Then only it will have a nose up and nose down, right? Then it will have only nose up and nose down. So you can say that angle of attack, right, keep changing. This actually I have a plan to not give the theory because if you write theory, maybe you remember or not. So better you just write the outcome. So outcome of the short period oscillation, because you understood what is the short period. So in the short period oscillation, basically there is the pitch up, pitch down, but it will have, yes, it will have a it will have a constant altitude. That is very important. Need to remember. So there will be rapid change in angle of attack, and that that at that the altitude will be a constant. And also I have this one is done. Should I go ahead? Should I go ahead? Yes. Okay. So third is nothing but that uh, constant airspeed at constant speed. These three things you need. Okay? This is usually highly damped. Usually highly damped means very fast. It will go up, it will go down, it will go down, like that it will be happening. That's the thing is what happening in short period oscillation. The short period oscillation. Okay. Now the most and very important here, as I have told you, the damped oscillation in a pitch goes up, goes down, nose up, nose down, but the altitude. Please remember this. Okay? This diagram, if you then you will get it. Now talking to the next, which is called a long period oscillation. So next one. long period, pitching. See, by the word only here you can see the long period pitching oscillation. Correct? So it is also called cuboid motion. What it is called? Cuboid. Cuboid. Please write down this. It is also called cuboid motion. Okay. It is very very important. What is happening here? Just write down the outcome. Then we'll go. The outcome is here we have a constant angle of attack. Please remember constant. I will show the diagram also. Constant angle of attack. Angle of attack will be constant here. The fugade is nothing but long period pitching oscillation. But in this case, the constant angle of attack for the aircraft have. Okay. Next, the very important parameter, that is the outcome again, that altitude will not be constant. So there is the change in or variable altitude. So we can say that altitude be uh, cyclic. There will be a cyclic altitude. It will be uh, up, it will go down, it will go up, it will go down. So there is the oscillation because you are writing here. See, oscillation will be there. So the altitude is what changing. Okay. It's keep changing. It's not constant. That is the main I wanted. And obviously, once the altitude is what changing, so the speed not be constant. So you can say variable speed. Variable speed. Always remember these 3 points for short period and long period. I have you just remember it, dear. Okay, it's very important. Always remember this type of the that also I have to write for uh, long period oscillation. Okay, long period oscillation generally are damped and convergent. Damped, uh, typically I will write here. It's a typically damped, damped and and convergent oscillation. Okay, now next we have to see the long period mode of the aircraft, long period oscillation of the aircraft. Basically, here, as I have told you, the variable altitude. So, variable altitude means that altitude keep changing. So, there will be the exchange because altitude is what increasing. It is going up, it is going down because oscillation is there. Once oscillation is there and altitude is also keep changing, you know that the aircraft. I'll show the diagram. Suppose the aircraft is what flying like this. Check it. Now, because of the disturbance, that aircraft will gain the altitude because the air comes and hit to the aircraft. So it will be gaining altitude like this. See, will be will be gaining altitude like this. Then again it will have a decrement. And this because it is the oscillation, so cycle will be formed. It will go up, it will go down, it will up, it will go down, it will up, it will. So I will show the exact diagram. So see, if you check from the reference, suppose this is the reference. So see the altitude, it is not constant, it is keep changing. See the altitude, but keep. That's the reason I have written variable altitude. I hope you understood. But at the same time, here I have not shown you that angle of attack. It may have a constant angle of attack. That angle of attack is not changing. Okay, but the thing is, just try to understand. Once the altitude is what changing, what will be happening? Think about it. Can you say in once the altitude is what changing with respect to reference? See, here altitude is what less. Here altitude is what more. Again, it is decreasing. So one cycle, if you say the oscillation is there, once will form a cycle, then somewhere there will be a zero amplitude also. I will show the another diagram. So the point is what I want to mention in this long period of pitching oscillation where altitude is what keep changing. Because of that, there will be the exchange of energy. Change of energy, think about it. Once it will gain altitude, potential energy will increase. Once potential energy will increase, kinetic energy will decrease because at very high at top velocity will be less. And once it will lose potential energy, means once it will lose the altitude, then kinetic energy will be increasing. Okay, so once the potential energy is high, kinetic energy will be less. Kinetic energy is high, potential energy will, and you know the total energy will. So think about it. Okay, so there will be a, in case of the, I'm talking about long period pitching, right? So in this situation, there will be a exchange of energy. There will be oscillatory motion. There is no doubt about it. Okay, and here the change in speed and altitude both will be involved. That's the reason I have written variable speed and altitude. So once altitude increases, speed will be decreasing. Altitude decreases, speed will be increasing. So altitude increment rho gh, potential energy is increasing. You know that, right? I'll show another diagram so you will be more clear about it. Very easy, but you need to understand. Question they are asking. Okay, pivot motion they had asked question. So I will show you one reference line. Suppose this is the reference line. Okay, think about it. Now, once the long period pitching oscillation for the aircraft will have, and once the disturbance came and hit to the aircraft, okay, so it will, suppose the aircraft is what somewhere flying like this. See, aircraft is flying like. Now, what is happening for the aircraft? You will have the disturbance, and that because of the disturbance, that oscillation will be formed something like this, like this. This is the oscillation. So obviously, that aircraft will be here, here. Check. So what is happening? You check. So once the think I will write each. So in this situation, see the aircraft is what climbing. Aircraft, aircraft, aircraft climbs. Yes or no? Aircraft is what climbs here. So once the aircraft is what climbing, then what is happening? Said already I have taught you. The aircraft will climb, then what will happen? Once the aircraft will climb, then what will happen? So once the aircraft is what climbing, then you know the lift is always greater than weight. That is the condition. Aircraft is what climbing, then lift is always greater than weight. That always happens during the climbing. And once lift is greater than weight, see once it is gaining altitude, so speed decrease. Correct. Now, now what is happening? This is the top one. The maximum velocity, because the speed is what decreasing, so once it reaches here, that speed is what minimum. I'm talking, not talking in terms of cruise and all. Okay, I'm talking about the energy point of view. That potential energy will be very high here, maximum. So the kinetic energy for the aircraft, I'm talking about the speed for, with what it is, with what speed it is going up and down, not I'm talking about cruise speed. So So speed will be minimum. Why? So speed is what minimum. That means kinetic energy is what minimum. Minimum. But what about potential energy? Check. Because of high altitude, potential energy will be max. Check. Similarly here, see potential energy here minimum. Potential energy is minimum. Then obviously kinetic energy will be maximum. I hope you understood. Because see, at this point, if you check, increasing speed gives a plane enough lift to pull its nose up. Pull its nose up condition, then enough kinetic energy. Okay, enough kinetic energy required here. So speed will be increasing ahead. So because potential energy is very less because the altitude is less, then definitely that kinetic energy will less potential energy, kinetic energy high, high potential energy, kinetic energy. Yes, that is the main idea because total energy is what constant. That you have to think about it. Okay. All right. So you take it in this situation. In this situation, there is the change of the exchange of the kinetic energy to potential energy and potential energy into kinetic. That thing is what happens. All right. Anyway, now so you have few assumptions for this. Okay, then we'll write the final expression for this. So few assumptions we have. What are the assumptions? The aircraft sorry, aircraft is initially in steady and level flight. Level flight. Right. The total energy. That's the reason I told you kinetic energy plus potential energy. I have to say the total energy of the aircraft remains constant. Okay, that you know. So based on this, okay, based on this, take it. These two things. There are two more assumptions, but just keep with this. So I have to write for the long period oscillation. Long period oscillation. Check the sum of energy. Sum of energy. Sum of energy is nothing but constant. Okay. Now we'll have a derivation for this. How to derive this? Check the basic idea. This is what the aircraft. This is what the aircraft. Suddenly disturbance comes and hit to the aircraft. Meanwhile, once it is because it is clearly mentioned in assumption, it will have a steady level flight. So steady level flight lift will be L naught, and obviously weight is nothing but M. This is the initial condition of the aircraft. The steady level lift is nothing but L naught. And suddenly that disturbance came and hit to the aircraft. So it should go like this, but because of the disturbance, it has changed the attitude and the path will be somewhat like this. The path of the airplane now. Now the airplane. Okay, so again that mg that weight will be in downside only. But if, see this is the velocity of the aircraft. Okay, right. So lift will be just perpendicular. But L naught and L both are different. Okay. And say that disturbance and this angle is nothing but theta. Because of the disturbance, that aircraft has changed the orientation. The orient. Correct. Now you see this height, you can say, where the aircraft is born now, the reference. So this height of the aircraft, you can say, from the base is nothing but h. The reference you have taken, that is the horizontal. This is the, you just say, reference. You see how to get the result, and this is nothing but steady condition, level flight, initial condition. Okay. Now check. So what happens to the, I mean, how that two condition I have given the total change, and the angle of attack is what constant already in long period oscillation. I have of attack must be this. Now you see it. The condition here I have told you that the initially the aircraft, here you say the velocity is nothing but, say the velocity is but be not here because initial condition. So what will be the energy? Check 2 points you have, point A and this is point B. Just equate the energy. How you will equate? Because you know the kinetic energy and sum of kinetic energy and potential energy for the aircraft is what remains same. So it is point A is equal to kinetic energy and potential energy at point B. Check it. That should be there as the mean of it. Correct. Now what will happen? Check it. What will happen if you apply? So what is the potential energy at point A? Obviously at point A potential energy is nothing but zero. Huh? Check it by your own. So the potential energy is nothing but zero at A. Correct. So, but at A, kinetic energy will be there. What will be the kinetic energy? The kinetic energy I will write here at point A. You also concentrate, understand. 1 by 2 m naught b naught square. B naught we are taking steady level initial velocity, right? So is equal to, but at point B, kinetic energy will be there. What is the kinetic energy? 1 by 2 mass will be same only. Velocity is what change, mv square. Plus there will be a potential energy. H height. There will be a potential energy which is nothing but mgh. There should, right? Take everybody. So what you can write in terms of velocity, what you can write? See 1 by 2, 1 by 2 this side. Take LCM2. So you can say mass cancel out to V square, V naught square is equal to V square. Take it. What you will get? You just see it's nothing but V square plus 2GH. Agree? This will be the equation number 1. This will be the equation number 1. Or इसी को और क्या लिख सकते हो? Or you can write see V square is equal to V naught square minus H. All right. So this is the equation number 1. See that derivation is not important at all, but you should know at least how it comes. Okay. So now you will calculate the uh, lift. Will calculate the lift at steady state. What will be the lift at a steady state? Means initial condition. So what is the lift I have shown you? It's nothing but L. Check it. It's nothing but L naught. So I can say L naught. L naught is nothing but 1 by 2 rho. What is the velocity? V naught square S in, right. Correct. So L naught is nothing but half rho V naught square S into CL. That will be the lift. First equation you have seen here, it is nothing but terms of V you have written. Okay. And obviously you will write that lift at height H is nothing but point B, and this is nothing but point A. Check it. So what will be the lift? Now see the lift is nothing but L here. Check at point B. So you can write L is equal to, what you will write? L is equal to, check it. L is nothing but 1 by 2 rho v square S into 2 and 3. Let's check it. Understand? So you take all three equations. 1, 2, 3. Correct? 1, 2, 3. So just manipulate. You have calculated V square is nothing but V naught square minus, uh, check what you have, not square minus 2gh. No? You just replace the value. You replace the value, then what you will get? See, from equation from equation 1, just write it. What you will get? Check, because you have already V square is naught square minus 2gh, right? The value you have, correct? Now do one thing, just because I want half rho v square SCL. This is only V square. If you multiply by half rho square in this equation, just multiply by 1 by 2, check rho S in. If you multiply, then what you will get? Half rho v square SCL you will get this side, and this side half rho v square half rho v naught square SCL. That will be the L naught, and here half rho v square also half half cancel out. So what you will get? Check it. You will get, I will write here 1 by 2 rho v square S L equal to 1 by 2 rho v naught square S into L. 1 by 2, 1 by 2 cancel out here. Then what you will get? Minus of H S. You will get this, right? You just multiply this. So you just replace this value. What you will get? This is nothing but L is equal to minus. Just write this value H S C L. Check it now. So I hope you are getting this. It's very simple derivation, but sometimes it is required. Small derivation, not typical. So this is the main equation you got here. What you will do? Check what you will do in this. Just replace, because you know F is nothing but M as per Newton's second law. It is nothing but M d by dt by dt. Correct? This value you can write dv by dt. Also, if you are writing in terms of the distance, so it will be dv by dt. You can write uh, e square x by dt square. Correct? That dv by dt you can write like this, and then you have mass. Okay. If you check, this one is nothing but force F as m, and instead of x, what you have to write? In which direction it is varying? Like in which direction? In direction of h it is varying. Instead of x, what you will place? You will place d square h by, hope you all are agreed, the Newton's second law. So because the object is what moving in h direction, so instead of x, what you will write? D square h by dt square. Why you are doing this? Because see, you want to write the uh, you want to write the natural frequency for that oscillation. So for that reason, if you remember the main equation in vibration, also in the form of uh, Newton's second law, inertia force we had written. So this is what, this is actually inertia force, correct? But inertia. Okay. Now you just check next what you will do here. As to see the basically this free body diagram, check nothing but L but M. So if you check this angle here, this is the direction of aircraft. This was the theta. So also you can say, take this component, you can write here. What you can write, see the component, you can say this is theta here. This will be L cos theta, right? You can write like this. So what will be the inertia force, right? The inertia force F in vertical direction. In vertical direction, what will be the inertia force? That will be L cos theta minus, take it. Take the diagram, you will understand. So the inertia force, because the aircraft is what gaining altitude, so the upward vertical component, if you write, inertia will be linear, right? So linear means in vertical direction. So F is nothing. So what is the F you have written? It is d square H by dt is equal to what you have written, nothing but L cos theta minus M. If you want to write cos theta, it's okay. Otherwise, for a small uh, angle of this theta, because it's a flight path angle, so that you can write L minus M cos theta approximate to 1, or can say like this. Okay. Now the problem is what sorted here. Have done already. You already have calculated L. Check in the problem. Have written L is nothing but L naught rho g HCl. In this format you can write. What will be the value? Ultimately, what will be the value here? Check, is nothing but, you can write this formula here. Check. Next, you can say M d square H by dt square. You can write MH double, just like a MX double dot. If you, this is nothing but L minus L minus L is already you have seen, it is nothing but L minus mg. And if you see the previous equation, L value you had written, what was that? Mg minus rho g h s L is the value of L minus m already. You just calculate that value. Mh double dot is equal to mg cancel out. You will have a rho h, right? H you can take this side. What you will have? You will have mh double dot plus of rho h s. The problem is almost sorted. You can write h double dot. What you will have divided by mass? It will be rho e s cl divided by mass equal to, check, is there. So if you write in this format, you can just compare with that your main equation. What was the main equation? Mx double dot plus kx. I mean, you want to write the natural. So you can write x dot plus k by m. See, x. What was the natural? Was the natural? W square is k by m. This was the things had done in vibration. Similarly, here also, what will be the frequency, natural frequency, because it's a long period oscillation. So long period oscillation also called phugoid. So pH I am writing. pH is nothing but C rho E H S L divided by mass. Correct? OGSCL divided by mass in rho. But natural frequency of the long period oscillation, which is called phugoid. Called phugoid. Correct? If you remember this, you'll be able to write the equation. Very important actually. So ultimately, if you see the standard format of this H double dot plus this value is nothing but W square H is just like your vibration equation. You see, for this, what you can write? You can write x double dot plus wn square, natural frequency of x is, and then wn square is equal to k by m. You can compare and you can write. So the main idea what you have written here, WPH. What is the WPH? This WPH is called phugoid, long period oscillation, also called phugoid. Okay, it's called phugoid. No? Long period oscillation also called as phugoid. Phugoid natural frequency. Always remember, okay, which is called long period oscillation. This is asked in your exam. It was mandatory to define for this. It was asked in your. See, the natural frequency of the long period oscillation depending on which factor rho e, okay, s el mass of aircraft. These are the factors. This is very important. Very important. And has been asked based on it is very important. Gamma, I have to say. So the conclusion is very clear. This single marks question they can ask now. 8. What question they can ask? That natural frequency of the phugoid or long period oscillation. See, depending upon what? It is the density. Okay? It is depending on the but natural frequency also depending upon the S. Obviously, it should third natural frequency of the third long period oscillation CL, which is and the very important that W also depends of a root. They can ask question any parameter they can ask and they say mass is what two times then what will be they can say the lift coefficient is what increased by 50%, then what will be the natural frequency. But so you can relate, see the formula in front. Easily you can relate, and it's very easy. It's not very difficult. Very easy actually. Okay. So that is the one thing I wanted to mention, and I wanted to complete today because this phugoid, uh, I, basically this result. If you check again, also you can change as per your requirement. This result you can change because this is in terms of rho g scl, but maybe it is required in terms of velocity. What you will do? What you will do? Check it because you have in this result have WPH. I will show you. WPH is nothing but what you have rho T S C L divided by mass. This is the value you have. Now, if you want to convert into velocities, what you will do? I had shown you for the steady level lift L naught was there, and L naught was because it's steady level, so it is equal to mg. This is equal to mg, right? So see, and also you know the lift formula. So what is the formula? 1/2 rho v square s in rho v naught square s into. So my point is, if they have given in terms of velocity, how to relate the phugoid natural frequency, we can replace that, and we can write the new formula. So it will be more clear to you because rho SCL. If you write the rho SCL, rho SCL. What is the rho SCL? Check. So you can say rho SCL is nothing but 2 mg. Check. Rho SCL 2 mg divided by E naught square. Check it. Check everybody. Correct. So instead of rho SCL in numerator in the formula, check what you have WPH, which is nothing but rho GSL by M. You have. You just replace rho SCL. Rho SCL, G you can keep because rho SCL means G 2 G into one more G will be there inside the root. Check it. Check by your own V naught square in and divide by M is also there. Check everybody. Rho SCL. So G is already there, okay? And rho SCL is 2 mg. So 2 mg into G divided by M. MM cancel out. What you will get? Check this formula. What I'm writing here, it's very special. And question they had asked. So see, mass cancel out. 2G square by V naught square, right? What you will get? Check 2G square divided by square in this is the main formula. You can check it. What you can write? Can you say this formula becomes but G divided by V naught, sorry, G divided by V naught, and that will, or we can write G, this is the main. See, this is the very finest formula and very useful formula for the figure for the numerical point of view. And obviously numerical will be asked based on. So can you say this WPH? Finally, the formula is nothing but 2 times T divided by V. See, this is very, very special. Now you can think that the natural frequency is what also. See, G is constant generally. We are not going to change in atmosphere at least. So even though it is 11 kilometer or 7 kilometer, our G is not changing. So the main idea, if you check the WPH, the natural frequency WTPH is nothing but uh, 1 upon V naught, which is very, very important, okay, which is very, very important for your uh, exam problem. This is very, very important. I hope you, right. Now, this is what the natural frequency. What is this? This is nothing but natural. Sorry. What about the time period? Time period. And you know the time period is the long time period. Mentioned long time period. Time period oscillation. At least you know what is the value for oscillation. Called phugoid, no? So you know the very standard formula. What is the time period t? The total distance for the circle 2 pi divided by angular velocity w. Because it is you are finding for the phugoid, so this will check it. Now TTPH for phugoid 2 pi divided by WPH. What is the WPH? The natural frequency phugoid, nothing but root T divided by V. Check 2 it will be what? Nothing but see one root will be cancelled out. We'll have a top, okay, pi will be pi not. This is very, very important. Just keep this formula with you. Ph can also calculate root 2 into pi. If write this, anybody can say root 2 into pi, so that constant also becomes the root into pi. Yes, 4.442. Correct? Just remember. 442. ठीक है. And 442 be not very, very important there. Okay. And I don't know why this time my intuition is what they are going to ask question from the few. This two formula you need to remember. This two formula, time period and natural frequency. So you will able to solve the question. Okay? This is what and time period and natural frequency. But as I have told you, initial only. This long period oscillation is the damped oscillation and convergent oscillation. Here I have written somewhere, na? Convergent and damped oscillation. Check it. So that also you need to remember. And long period oscillation, the damped oscillation, the damped oscillation. Not written, you can make a note of. Yeah. So long period pitching oscillation is the damped oscillation or convergent oscillation. It is damped oscillation or convergent oscillation. Definitely, there will be a damping uh, factor. There will be a damping ratio that time. Damping ratio also sometimes they are asking. It's very very important. Damping ratio. Is they had asked three question based on it, based on the damping ratio, because you have seen long period oscillation is the damped oscillation. It is the convergent oscillation. So if it is a damped oscillation, so there should be damping factor, damping ratio. Yes or no? So what is the formula for that? Just write down the formula here. I will write the formula. Damping damping ratio. Okay, damping ratio, or so called damping factor. Damping or damping factor for a phugoid motion. What will be the formula? That I am just going. It is damping ratio. You know zeta. The P. The this formula you need to. This is nothing. This is the one derivation, but again it will take time. So I'm just basically it is nothing but CD by you can write CD by CL, or also you can write the 1 by root 2. You can write drag, because you multiply half rho v square. As half rho v square in numerator and denominator should be drag and check. So this zeta H, nothing but damping factor, also be depending on the 1 by 2. See, again I am writing this formula, please listen. Okay, by CL, also you can write 1 by root. This is nothing but drag by lift. Also I can say 1 by root 2. No, this 1 by L by D. What is L by D? Ready? Is L by D?
E.
It is E, correct. 1 by root, but aerodynamic. High aerodynamic efficiency, less damping factor or less damping ratio. That also very powerful relation can be asked to you. E is nothing but aerodynamic. E is nothing but L. मतलब L by. That also they can ask. They can give that the aircraft that flying with the aerodynamic efficiency of 10. They will give some statement and they will say, okay, find out the damping ratio. आप बोलोगे डैम्पिंग रेशियो यहाँ कहाँ से आ गया, वाइब्रेशन कहाँ से आ गया, तो नो, because long period oscillation is also called damped oscillation or convergent oscillation. If it is damped oscillation, so damping ratio or damping factor should be there. Then only it is called damped oscillation. This is the formula of the damping factor. Please remember. I hope you all understood. From my side, today I have completed this short period pitching oscillation and long period pitching part is done. Next class again I will continuous this, and then I will talk about the few things about lateral and directional types of, like spiral, touch roll, and then we'll talk about the Routh criteria. Based on that, not one time, multiple time question has been asked. 2 marks question they have asked 3 times based on the roots, imaginary roots, real roads, when it will be Dutch roll, when it will be divergence, like that question they had asked. Okay, or it is short period oscillation or long period oscillation. For that, you should know the roots. So definitely will continue two lectures more. Basically, will be completed.